When I usually do a long lecture, then we do a sort of a small break, right? So if you were in the actual class, you will go out for a few minutes, take a physical break, drink some water so that you are refreshed. And when you come back, we will have what we call a small mental break. So for a few minutes, 2-3 minutes, you are talking of something totally different from your course. So mentally you are taking a break, right? I am from Pakistan, the northern areas of Pakistan and Afghanistan. You hear a lot about them. There are people there who are called Pathans. The last name of every Pathan is Khan, K-H-A-N. Our Prime Minister today, Imran Khan, also belongs to that category, Khans, right? So these Pathans are there. For 3 years, I was at a university in the northern part of Pakistan, living in those. So they are really great people, very hospitable. They will always, I mean, you are totally unknown, but they will invite you for lunch and dinner and so on. And they are very religious also. Whenever I used to travel on buses and public transport, if it is a salah time, then the driver of the bus, he will just stop on the side of the road and he will, I mean, take out masalla and so on and say, if you want to join me and so on, we are stopping for prayers. And then he will continue. He will not wait for a masjid and so on, right? So they are very religious and so forth. So now this is just, but this is just a joke, right? This is just a joke. So there is this Khan Saab, Pathan Bhai Khan Saab. He goes to the masjid regularly, and one day Jummah prayers are there. Jummah prayers are finished, the khutbah was there, the prayers were there. As soon as the prayers ended, he starts running from the 3rd row or the 5th row and so on, goes to the imam and starts hitting the imam. Now all people are, everybody comes, Khan Saab, they are stopping him. He starts hitting them again. He said, Khan Saab, what happened? Khan Saab, what happened? This is a very bad imam. He says very bad things. He starts hitting him again. People separate them and say, Khan Saab, what happened? He said in his khutbah some very bad things. What did he say? He said, if you feed a poor person, you will get Jannah. Start hitting him again. People said, separate. Khan Saab, what is bad? No, he said more bad things. He said that if there is an old man, you help him cross the road, you will get Jannah. Again hitting him. Khan Saab, these are good things. What is the problem? No, everybody will get Jannah. Everybody will get Jannah. So what is the problem? Jannat is the name of my wife. Okay, right? So back to planning for prototypes. We were just saying in the previous slide that Exhibit 14 is there for planning, right? So these 4 things: define the purpose of the prototype, establish the level of approximation of the prototype, outline an experimental plan, create a schedule for procurement, construction and test, right? So this is not for the product, remember, right? This is for the prototype, but prototype is also to be designed and material has to be procured, and the manufacturing of the prototype has to be planned, right? So plan milestones of the prototypes, alpha, beta, pre-production. So let us see how it goes. So this is Exhibit 14, planning template for the PackBot wheel geometry impact test prototypes, right? Name of the prototype and PackBot wheel geometry impact test. Purpose, level of approximation, experiment plan, a schedule. So different types. Select final wheel spoke geometry and materials based on strength and shock absorption characteristics, right? So only for this one, right? This is the name and these are the purposes and so on. So they had made, we have shown you lots of different prototypes. So this is only the wheel prototype for geometry and impact test. So what was the purpose? Select the final wheel spoke geometry and materials based on strength and shock absorption characteristics. Confirm that the wheels absorb shock to withstand impact and protect the packbot and its payload. So this was the purpose of this one. Level of approximation, correct wheel spoke geometry, materials and platform load. So this is a very, very real physical one. Actual geometry, actual material, actual loads. Experiment plan, build 12 test wheels using 6 different materials, each with 2 spoke shapes. Mount the wheels to the test fixture, conduct impact tests at a range of drop heights, different drop heights. So this is the experimental plan. And then they had some schedule. 1 August do this, 7, 14, this, right? Select wheel design and material, complete design of test fixture, wheels and test fixture and so on. So this is a big thing. This is just like a small design of product itself, isn't it? It is a product design within a product design. Each prototype is a small product by itself. So the whole product design is going on, but if you decide for certain types, so that is why this planning was very important, which we discussed earlier in this lecture, that if you go for prototyping, then from the beginning, conceptual design level, from the beginning, try to plan that what different types of prototypes you want to use, and then plan like this. For each type of prototype, have a plan like this, that what is the purpose, what will you actually approximate, how will you do the experimentation, what will be the schedules and so on. So these small sub designs, and this is not a design, this is design to production, because prototype means you are actually producing, except when it was a software type of prototyping. But if it is a physical prototype, then you go through the design stages and then you manufacture it also, right? So this is very critical. So you see, we repeatedly tell you that in an introductory course on anything, this is your first course in design, and you have already learned a lot, and in the remaining chapters you will learn a few more things. Now this chapter was only about prototyping. So we have tried to give you an overall very good view about prototyping, all the different things. What is it? How is it defined? What different types are there? How do you manufacture it? How do you conduct it? How do you plan for it? And so forth, right? And what are the principles and so forth. So this is enough of a background for prototyping at an initial level course on product design. You know, if you are mechanical engineering, then you will do a second course called capstone design. So you will do this, all this again at a higher level, and you will do a design of thermal systems. So you will apply all these principles again to products which are thermofluid in nature. And of course, whether you are industrial or mechanical, you will do a final year project where hopefully whatever you design, you will construct and make. So you will be doing actual prototyping in one sense. So you will do this later on also. So this is the end of this chapter. After this, now we will quickly try to summarize what we have covered until now. In summary, product development requires building and testing of prototypes. A prototype is an approximation of the product. Classification means physical versus analytical and comprehensive versus focused type. Prototypes are used for learning, communication, integration, and milestones. Several principles are used to guide prototypes decisions in product development. Analytical prototypes are more flexible than physical. Physical prototypes are required to detect unanticipated events. A prototype may reduce the risk of costly iterations. A prototype may speed up other developmental steps. A prototype may restructure task dependencies. 3D CAD modeling and freeform fabrication technologies have reduced the relative cost and time required to create and analyze prototypes. Milestone prototypes, numbers and timing are vital in the overall development plan. So after discussing the overall summary of the whole chapter, again, analytical prototypes, right? 3D CAD rendering, right? Dynamic simulation model, FEA, finite element of wheel spoke geometry. So these were analytical types, examples of analytical prototypes of the PackPod, 3D CAD rendering and so on, finite element, dynamic simulation. So all this is either done as a 3D drawing or a 3D simulation, right? So these are analytical prototypes. Prototyping technologies, right? Exhibit 12, finite element analysis of the PackPod side plate based on the 3D CAD model. The image shows the stress distribution upon side impact at the rear wheel, right? So 3D CAD modeling and analysis, virtual prototyping, but this time it is not just the geometry. You have applied loads and you have done a side impact from the side. So if there is an impact from the side, what will be the stresses and deformations and so on? You find all of that, isn't it? Virtual crash testing of automobiles, actual, right? But this is not physical, virtual. You have done the full 3D modeling and so on, and you virtually crash the car into the wall and so on and see what happens and so forth. So this is prototyping technologies, right? The soft technologies. Then in the prototyping technologies, the free-form fabrication, right? So stereolithography. So this is the whole machine. This is the sort of a schematic diagram. Ultraviolet light source is there. Elevator with platform is there. Photopolymer surface is there. Layer-wise built, layer-wise. Liquid photopolymer is there. First layer, second layer, third layer, you will keep on building and so forth, right? So this is additive manufacturing, but as you see, this is using polymers. Of course, the choice of polymer and so on, there will be some things. So here you will not use the actual metals or the actual ceramics that make your real product, but based on this polymer, very quickly, within a few hours maybe, or even less than that, you can make the actual product, but out of a polymer. Now you can see if all the parts fit together, if they work together. Of course, the real crash test, the real force tests cannot be done on that. So this is free form fabrication, right? Furthermore, on free form fabrication, for example, the PackPod prototype shown in Exhibit 3A, which we did earlier, was made of components fabricated using stereolithography in only 4 days. This is very complicated. So it took 4 days. The real product, I don't know, will take how long, right? So the prototype can reduce the product development time and improve the resulting product quality. It is used to represent product concepts quickly and inexpensively, and it eases communications amongst the team members, managers, development partners, potential customers, and so on, right? So this was a quick summary of all the things that you have done in the chapter. And just very quickly, for prototyping technologies, some websites and so on, most of these methods are additive rather than subtractive. Build parts in layers based on CAD model, stereolithography apparatus, selective laser sintering, 3D printing, laminated object manufacturing. If you are interested, you can go through all these websites and you can actually explore what the method